Hello, my dear friends, my dear viewers, and my dear subscribers. Thank you so much for another day like this. Today we are going to learn something different, a new topic indeed, the basic AC circuits and their applications. That's what we're going to learn today. Right on the board is a diagram that illustrates an AC variation with time or an AV variation with time. AC stands for alternating current. AV stands for alternating voltage. Then the variation of alternating current with time is this. Also, the variation with alternating voltage with time is also represented as you can see on the board. So what we're going to learn today is what happens when we have an alternating current flowing through a circuit, and also what happens when we have an alternating voltage flowing through a circuit. Without wasting time, an alternating current or alternating voltage is one that varies. It varies sinusoidally or periodically in such a way to reverse its direction periodically or sinusoidally. That's what it means. That's what the definition stands for. The same thing applies to alternating voltage. Of course, we should understand that we cannot generate currents if we do not generate voltage. In the actual sense, the generation of voltage leads to the production of current. Alright? So that's what happens. Once voltage is generated, current is also generated. That's one fact that I want us to take note of in the first place. Now, the next thing is this illustration, this statement has been illustrated in the diagram above. Now there is a mathematical representation of this statement, and that is what we have over there. The mathematical statement is given as thus: I equals to I naught sine omega t. Why do we use sine omega t? Because this represents a sine wave. That's why we use sine omega t. I'm going to take the time to explain all this one at a time. So, because this represents a sine wave, if you are familiar with what sine waves are all about, we have sine waves, we have cosine waves, and we have tangent wave. But regarding what we are treating today, or what we are learning today, we are only referring to sine wave, okay? And that sine wave is included in this relation. I equals to I naught sine omega t. That's how that factor sine omega t comes into play. I remember last time in my previous video I also treated a wave profile where we explained in detail the meaning of sine wave, okay? Alright. Now the second one, I equals to I naught sine 2 pi ft, meaning that the omega, which represents the angular speed of the particle, all right, or the current, the angular speed of the particle or the current. If we are referring to wave, we call it particle, and so on and so forth. So this is 2 pi ft. That's this. That is what it means. Now, where the parameters retain their usual meanings as I, then the meaning of I, just the I, is instantaneous current. And current, as we know, is measured in ampere, in abbreviation amp, that is A. I naught, this is I naught, okay, represents the peak value currents of the alternating current flowing through the circuits. Alright? And that is also measured in amps. So that is clear as we know. Now, having explained that, we typically have the F. F is frequency. Frequency, the number of cycles per second, right? And it's measured in hertz, Hz. Very clear. Then time, as we have it there, is measured in seconds. Then the omega here represents the angular speed, measured in radian per second. If we understand all these parameters, we'll be able to solve problems coming from anything that has to do with AC circuits and applications. That's the reason for taking the time to explain these concepts. All right? Now, if we have current, recall I said current. We cannot have current without, first of all, generating the voltage. It is actually the voltage, that source, that forms or generates the current. So in the presence of voltage, there is also current. So that's what happens. Okay? If we have current in that form, we also have voltage in the same form, where V represents the instantaneous voltage, V0 represents the peak value voltage, and then we have all these explanations before. So that's what it means. Okay, having said that, and I know by this time you must have watched to this extent and you are finding value in what I am doing. Subscribe, come on. Give us some thumbs up, share with your friends, network, and students. Remember to put on the bell button for constant notification. My returning subscribers, my new subscribers, thumbs up for you. Thank you for patronizing this channel. Make it go viral, come on. There are students in science that need something like this. Push it to them, encourage them to learn. That's what you can do for me. All right, back to what we're saying. What are we saying? That we can only have current in an AC circuit or AV circuit when there is voltage, which forms the source or the supply of such current. That's what we're trying to say. If we have understood that, all these parameters, very, very important. If we understand them and how to apply them in various AC or AV circuits, then we won't have any problem solving any problems. The next thing we need to understand is peak and the RMS values of AC. Peak and what? RMS values of what? AC. One thing is missing here. It should also be AV. It should also have AV because we have peak as well in that aspect. Okay? So that is it. So what is the meaning of peak values of AV in terms of current and in terms of voltage? Let's take it one at a time. All right? Let's take it one at a time. The current, RMS. RMS means root mean square. So when we have current in an AC circuit, that is alternating the currents flowing in a circuit, we must find out what the root mean square current is all about. And what does it mean? Root mean square current simply means that steady current that must flow in an AC circuit, producing the same quantity of heat in the same resistance in the same time. That is it. I repeat, root mean square value of current in an AC circuit is that steady current that must flow in an AC circuit, producing the same quantity of heat in the same resistance and in the same time. That's what it means. Okay? If you understand that, the next thing, apply the same concept, the same understanding, the same definition to AV. All right? Good. If we do that, we take note of this when it applies to current. So the root mean current value can be calculated when we have the value of I0, which is the peak current, over root 2, square root 2. All right? Or root 2, so to say. If this is confusing, we can split it. We can simplify this further by saying that root mean square current is given as 0.707 I naught. So this is the simplest form of it. And with this, we get what we want and arrive at the answer. So that's what we have today. It's very clear. If any part of my definitions or explanations are not clear, take the time, put it in the comment section. Tell me that this is not clear to you. You want more definition or more explanation. I will do it in my next video, okay? I will take the time and explain more or further on that. If you don't understand anything here, once again, as you are considering subscribing, giving me some thumbs up, sharing with your networks, students, and friends, putting the bell button on for constant notification. Remember to put your concern, state your concern in the comment box, what you want me to do. I will do it for your learning pleasure and gaining knowledge. I am signing out. See you in my next class, where I will put on my lab coat to solve some problems associated with basic AC circuits.